Hello guys, welcome to another video. This is your IB guide. Today I'll be showing the basics behind modeling a mathematical model using Excel sheet. So first of all, let's consider the function y is equal to x squared, okay? And usually when you want to write a model, it's going to be way more complicated than this. So for example, if you want to model this model, and let's say you want the x to be in intervals of 2, okay, this is the first thing we're gonna do. Okay, we're gonna click the equal sign and then click on the top button, the top square, and then we add 1 or 2, let's say, because we want it in terms of intervals of 2, and there we go, we get the number 3. And you do this for as much as you want. For example, I want it up to here. And then what you want to do is you want to create the function. So here you also press equal to, and now instead of going to each number and writing it, you can simply click on the value of x, and then shift 6 2, that'll make it squared, and 1 squared is indeed 1. And if you scroll it down, the same thing is gonna happen, and you're gonna get these values. Now what happens if you have a constant in front of this value, for example 2? What you could do is you could do the exact same procedure as we did before. Then you add 1, for example, and then all you have to do is do 2 times this number, equals to 2 times this number squared. And you scroll it down, and this is if you have a constant. Now what if you have a constant k, and k is equal to 256? How would you go about this function? You could do it the same way as we did before. However, the next example is going to be a little bit more complicated, since this constant is shared among 3 functions. So in this case, we do the exact same thing. Let's have this, for example, in terms of intervals of 3. And do you want to do that? Then you're going to choose this times 1 squared. However, this will not work, as you can see when I scroll all the way down. It's gonna give the values of 0, which is not true. So basically all you have to do is, because if you see here, this is 03, O is here, this is 03, and if you go to the one below it, it's 04, and 04 is blank, which Excel interprets as 0. So basically all you have to do is you have to go back up to this function and press F4, or just put the dollar signs in manually. So here, for example, you're gonna click on this, and then press F4, enter, and then you scroll down, or you drag the box all the way down, and then voila, you get these numbers. Now let's look at a more practical example that you would use for an IA. Now if we move on to the next model, we're going to look at a more complicated model. So this is basically the SIR model, which stands for susceptible, infected, and recovered or dead. Okay, so this is extremely relevant nowadays due to the coronavirus pandemic. You can gain a lot of points on personal engagement. So when looking at this model, we have to consider these formulas. These formulas are basically a given. You could derive it using assumption laws. However, if we look at how to get the values, the rest of the values, and create an actual model, we're going to look at the value for the susceptible. The value susceptible is the whole population minus 1. So basically, in this case, our population is 1,000,001. Okay, and from that population, only 1 was infected, and of course, the recovered, no one yet recovered in the beginning of the pandemic. So the number of recovered is 0. So now you wanna model it. So first you have to consider the rates of change. So basically, what does IAT minus 1 and ST minus 1 mean? It basically means the one before. So this is before. So basically here what we're doing is that we're adding, if you see here, we're adding E2. E2 is this block here, this cell. And when we add E2 to this value, of course E2 is going to be a negative number from the formula. It's going to decrease, so someone's going to move to the infected and somebody's going to move to the recovered. So as you can see, it's not really an accurate model since it's given a decimal point. You can't have a decimal point of a person. However, this is how the model is. Okay, without further ado, let's solve it. So as you can notice here, we have the dollar signs as we did before in our previous examples. And basically now all you have to do is drag it down all the way, drag it down. It's going to be 0 for now, since we need these blocks. So you drag it down. Okay, perfect. Now all you need to do is do the same for this, and the numbers should start to appear here. There we go. And for the last one, there we go. So basically this is our model, and if we want to extend this a little bit further, let's say to right here, 127, and let's do the same for this. So extend all the way down, extend that too, extend this, okay. So usually what would happen is that these numbers start to become, and anyways an error occurs, and if you increase this number, the error should get delayed. There we go, now it's gone. So since I didn't calculate this number, I just assumed it should be really small. This is basically the rate of transmission, and this is the rate of recovery. So now that I have all the values, all you have to do is select all of this. Oops, no. Select okay, select it from the bottom then. select it from here, from the bottom to the top, I think. No? Okay. Yeah. Basically, all you have to do is do that. Let me put back the S and drag it across from the bottom, and there we go. Then you want to insert the scatter line. Okay, let me try this one more time. Okay, let's start it from the value of t. Okay, now I've got it. There we go. Oops, forgot the R one last time. Yeah. Okay, then we create a scatter chart. Okay, now the reason why this is like this is, again, these numbers are too small, so it should not look like that. There we go. This is how your graph should be. Of course, you're going to calculate this number, so you shouldn't face the same error that I've faced. Yeah, this is basically how the SIR model looks like. The number of susceptible increases gradually, and the number of infected increases, then reaches the maximum point and goes down, and the value of R increases steadily until it plateaus. And that means that the whole population, or at least part of the population, has recovered. So this is a really good idea if you want to use it for the IA. If you enjoyed this video, please don't forget to like, share, and subscribe, and hit the notification bell to be alerted when we make a new upload.